Hi there, and welcome to this lesson. In this lesson, we'll be learning matrices, okay? So matrices, and under matrices, we'll be learning to multiply matrices. So in the last lesson, we learned about some properties of matrices, and we also learned to add and subtract matrices. We learned about scalar multiplication of matrices, where we're multiplying a number by a matrix. But this time around, we'll be learning to multiply one matrix by another matrix, okay? And as the lesson progresses, anything you don't understand, anything comes across as unclear, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, matrices, multiplication of matrices. Now, it's multiplication of matrices. It's actually really simple. Okay, quite it's more complex than addition and subtraction of matrices, but then it's okay, let's just try and understand it. So multiplication of matrices, now I need you to pay very close attention. All right, like I said, it's simple, but one, it's prone to errors, okay, and it's a bit cumbersome. All right, so but let's get right into it. So first thing, two matrices can be multiplied. Two matrices A and B can be multiplied when the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay, so if you have a matrix, for example, let's say you have a 3 by 2 matrix, you can multiply a 3 by 2 matrix by a 2 by 3 matrix. Okay, so basically the number of columns and the number of rows must be alternating for you to be able to multiply the two matrices. Okay, now when you multiply a matrix of the order 3 by 2 by a matrix of the order 2 by 3, the product AB would have the order, so it would take the row of the matrix A and it would take the column of the matrix B. So if you have 3 rows in matrix A and 3 rows and 3 columns in matrix B, what you end up having is you would have 3 by 3. And if you actually flip that around, if you multiply a 2 by 3 matrix by a 3 by 2 matrix, you would end up with 2 by 2. So basically you take the two numbers at the extremes, all right, and basically you have, for example, if you have 3 by 2 times 2 by 3, you end up with 3 by 3. If you have 2 by 3 by 3 by 2, you end up with 2 by 2. Okay, now and then basically AB does not equal BA. Okay, so for example, like I just explained, if you have you multiply one, you end up with a 3 by 3, and then you multiply the other one, you would end up with a 2 by 2. So AB multiplying A times B does not equal multiplying B times A. Okay, so these are just a few rules, all right, but let's get right into the actual thing. Okay, so we have this we're looking to multiply. We have a matrix A and we have a matrix B, and we're looking to multiply to give us a matrix C. All right, now this is our matrix A. Our matrix A is a 3 by 2 matrix. Okay, so it has 3 rows and 2 columns. Okay, and with each of the elements in the matrix A, we have in the first row and the first column, we have an element A11. Okay, what that means is it's in the first row and it's in the first column. Okay, and then we have an element in the first row and the second column, A12. Okay, and then we have an element in the second row and the first column, A21. Then in the second column and in the second row and the second column, A22. In the third row and the first column, A31. In the third row and the second column, A32. Okay, now similarly, we're going to multiply this by a matrix B, and matrix B is a 3 by 2. Oh, no, is a 2 by 3. So you have 2 rows and 3 columns. Okay, so it's a 2 by 3 matrix. All right, and the element B, the B element in the first row and the first column is B11. In the first row and second column is B12. In the first row and third column is B13. In the second row and first column, B21, and so on. Okay, I'm going to multiply this to give us a 3 by 3 matrix C, where the elements, we have C11 in the first row, first column, C12, first row, second column. Now, when you're multiplying matrices, it's very important to note where the elements are. And that's why we've actually assigned this A11, A12, B11, B23, and etc. and C33, C21, C22. Now, it basically tells where it tells you the element in what row and what column. And this is the trick. Okay, now watch closely. If you have to obtain, when you multiply two matrices, okay, to obtain, and you get the result C, to obtain the element in the first row and the first column, that's your C11, you make use of all the elements in the first row of A and all the elements in the first column of B. Let's get that again. Okay, so you're multiplying two matrices to give you a product C, okay, and you have the element in C that's in the first row and the first column, okay, that's C11. To get that element C11, you make use of all the elements in the first row of A and all the elements in the first column of B. So to get the elements in the first row and first column in C, you make use of the first row of A and the first column of B. Now, if you were looking to find the elements in the first row and the second column, that's C12, you will make use of the first row of the first matrix is the row matrix, okay, you make use of the rows, and then the second matrix is your column matrix, is the one where you make use of the columns. Now, if you're looking to find the element C12, basically the element in the first row and second column of C, you make use of the first row of A and the second column of B. Now let's break this down. So like I said, C11, you make use of A11, A12, okay, so the first row of A and the first column of B. Now this is what you do. You multiply A11 by B11, okay, so you multiply the first element on the row there by the first element there, and then you add that to A12 plus B21, okay, so A11 goes with B11, okay, and then A12 goes with B21, all right, and then you add your results together, and that's how you get C11. Okay, now it looks a bit complicated now, but when you actually start working the multiplication of the matrices, you find that it's actually really easy. All you need to know, all you need to remember, and basically you just do A11 times B11, A12 times B21, all right, and then you add your results together. But what you really need to remember is, depending on the position of the element in the result C, okay, if you're looking for the element, for example C32, you make use of the elements in A, the third row of A, and the second column of B, okay, and basically what you would have there is you would have A31 times B12 plus A32 times B22, okay. It looks long, all right, but just think about it. Let's pick out another one. If you're looking to find C23, okay, so that's the element of C that's in the second row and third column. You make use of the second row of A and the third column of B, and that would be A21 times B13 plus A22 times B23. You see how easy it is to, and let's do one more. So let's do C31, okay. Now if you're looking to find the element C31, you're going to be making use of C31, so that's third row, first column. So you're looking at the third row of A, first column of B. That would be A31 times B11 plus A32 times B21. Okay, simple. All right, so we'll just break all of it down. C12 is A11 times B12 plus A12 times B22. C13 is A11 times B13 plus A12 plus B23, and basically you get the idea at this point, and you basically do this up until you get to C33, and then you would have obtained results for all the elements in your answer C. Okay, now here's a question. So let A be a matrix. So A is a 2 by 3 matrix. Okay, no, a 3 by 2 matrix. So A has 3 rows and 2 columns. Okay, and then B is a 2 by 3 matrix. B has 2 rows and 3 columns. Now we've been asked to find first AB, and then BA. All right, now we're going to go ahead and do this. Okay, so we have AB is A times B. Okay, and now we're going to be making use of the rows of A and the columns of B. Okay, rows of A and the columns of B. And to do that, we first of all need to identify our matrix. Our matrix is, we have a 3 by 2 multiplying a 2 by 3, so our matrix would be a 3 by 3. So you just take two numbers on the extremes. Okay, 3 by 2 multiplying 2 by 3, our matrix is going to be a 3 by 3. And basically this is what we have here. For the first element there, the first element, we have the first row of A multiplying the first column of B. Okay, so we have 2 times 1 plus 3 times minus 1. Okay, look at it. First row, first horizontal row of A multiplying the first vertical row, first vertical column of B. So we have 2 times 1 plus 3 times minus 1. For the element in the first row and second column, we're going to be multiplying the first row of A by the second column of B. Okay, and we have 2 times 3 plus 3 times 0. Okay, and then for the third element there, we have for the third element in the first row third column, we're going to multiply the first row of A by the third column of B. So what we have is we have 2 times 2 plus 3 times 6, and we do this up until we get to the end, to the final element there, and we just simplify that out. Okay, and we should end up with a matrix minus 1 6 22 2 0 minus 12 minus 1 12 38. Simple, straightforward. That's it. Okay, it looks a bit and it's actually, so you need to be very careful when you're solving this because it's prone to errors. You can make mistakes quite easily. All right, the actual underlying principle is quite simple. All right, for every position element in your product there, in your result, you just make use of the row of A and the column of B. If you're looking for the element in the second row second column, you make use of the second row of A and the second column of B. It's quite simple. Okay, let's do B times A. Okay, now B times A, we have a 2 by 3 multiplying a 3 by 2, so our result is actually a 2 by 2. Okay, and this is how we work it. You see, this time around we actually have three sets of products there. Okay, for each of the elements in the matrix there, because this time around we actually have for the rows, we have basically, we have for, if we're going to get the first element in C there, we're going to multiply we're going to be looking at the first row of B multiplied by the first column of A. So we're going to go 1 times 2 plus 3 times 0 plus 2 times 4. Okay, and then we do this up until we have all four elements of C, and we'll work that out. We'll end up with 10 7 22 27, and as you can see clearly, A times B does not equal B times A, and that's it. That's how you multiply matrices. Actually really easy. You just need to get that fundamental. When you're looking for the element in C, element in the product that's in the second row and third column, you make use of the second row of A and the third column of B. Okay, just once you have that at the back of your mind, you have absolutely no issues multiplying matrices. Okay, and yeah, that's it. Very simple lesson. Can we divide matrices? We can actually. Okay, there really isn't a process for dividing matrices, but what we do is if you're really looking to divide a matrix, if you want to say that, you basically multiply. For example, if you have A divided by B, what you do is you multiply A by the inverse of B, so you have A times 1 over B. And we would learn to find the inverse of a matrix, okay, over the course of the next few lessons. And yeah, you can go ahead now and attempt questions on the worksheet. Bye for now.